I have prepared this logical diagram for which we need to generate the PLC code. Let me develop the logic in CoDeSys so it can be device agnostic and easy to test.
Hello friends. So what we saw right now is the way we work in the OT world, correct? So we get the requirement in form of function block diagram, in form of cause and effect, or user requirement, and then we start developing the code into the PLC. But what if I say that in spite of doing that, we can directly create a model, okay, in form of FBD or in form of cause and effect, and then there is an application which can generate the code for me, so I don't have to do it twice. So I define everything at one place and then it will generate a code for me. So let's see how exactly we can do. And there is a software called Selmo. So I was using this Selmo Studio for checking few of the things and I find it interesting, so I thought to share it. So first we need to, of course, install the software. So I have provided the link in the description, so from there you can download, and also you can check the manual from which how exactly we can install the software and what all the steps we need to follow. So this particular software is a licensed software, so they are providing us a trial version also. So in the manual we have a section where we can go in for the request for the trial license. When you go there, we can click on the link and then it will take you to fill a form where you need to provide your basic details, and it will take 1 or 2 days to get the license into your mail, and also they will send you the link to download the Selmo Studio. Okay, so once you have got that, then we can install. So there are some basic prerequisite that .NET Core is needed, which we need to have in our system, and then we can follow the guided workflow of the installation to get it installed. So once the software is installed, then we can open it, and once you get the license, then you can be able to activate the license. So there are the problem that we can see that the online license sometimes doesn't work, so you can reply them back and get the offline license also, so they can be able to provide you. Right now I'm trying to install this particular license. This is an online version of the license, and if you see that no internet connection and cannot be activated trial period license. So this error sometimes can come, as I told. So for this particular thing, what we need to do is we can ask them for the offline version of the license, and they should be able to provide, and then we will be following the same procedure and it will get activated. Okay, so first we need to create the project. So that is the initial phase for anything. So we need to open the software, click on the file, create project, and provide the file name, and then it will create a structure. So the structure goes in a very similar way as any software goes with. So it has the first project description, so everything what are the properties of the project, it will be there. The main thing which we need to choose in this one is the target system, because it supports multiple target, so like back off, Lang, Control X. So I'm choosing here the CoDeSys control for Windows. Okay, then we need to provide here the OPC server address. So as it is a Windows v3 x64, so I'm providing it the localhost. License part I'm not talking here because we are using the trial license, so that will not get sufficed. Now the project notes, so we can create and write all the notes here for the particular project, how exactly it will be, what all the things, so that we can write it in this particular project notes. So it is just like a notepad file, so what file we can say. The main thing which starts with the plant. So in the plant, first thing is we have the TCMZ parameters. So in the parameters we can define the different variables. Then the hardware zone. So hardware zone is actually contains for the input, output, defining the logic, everything will come in this. So now if you see, I have just defined here what exactly each section means here. So hardware zone, sequence, logic layer. So logic layer is used to pre-model the steps of the model, the graphical interface. Assembly layer is something. So I will go through each one by one and show exactly how we are going to use it. Okay, So let's start with the logic layer, because that is where we will be writing our whole logic. So now we are in the logic layer. So if you see in the logic layer, we have the palettes defined like steps, timer, decision, jump, repeat, and cross sequence. So I will create here a very basic logic. So just by defining a step, so how exactly we define the logics in PPT, or we define in a functional block diagram, correct? So I'm defining it like, first we have taken the step. So if you see the step, the first step, I'm using it like a open valve command. Okay, so I'm using it for the valve, so open valve command. Then I will wait for some second to get the feedback. Okay, so that's the logic, and then I will give a command to close the valve and then wait for some time to receive the feedback. So this is the small sequence which I'm trying to simulate or create here. So the basic thing which we need to take care is what will be the steps, how the timer should be utilized. If somewhere we have to use some decision making, then we can utilize the decision making palette. So all those things we can use, but here I'm just going with the steps only. So if you see how exactly I'm trying to create it. So valve open feedback I have given here. Now I will again give a small timer. So in the properties, we can be able to set the time values, what the timer has to run. Then and also the steps which we are creating, we can also define those steps, whether it will be a start step or whether it will be end step. So that has to be also taken care, which is given in the properties. Okay, so let me just put again one timer in the steps, and then the last step will be closed valve feedback. So valve close feedback we can get. So if you see, I'm just defining here just the block diagram, nothing else apart from that. Now once we have defined the block diagram here, we will go to the assembly layer, because what exactly we need to do. So in the assembly layer, we have some predefined assemblies. We can also create our own assembly, but for this particular demo, I'm going to use a predefined assembly like automation. We have control engineering, operation. So in the operation, if you see, we have the push button. So when we are giving the command to any valve, we utilize normally the push button, so on, off, or open, close. So that's what we will define it here. One push button is needed, correct? So I'm defining a friendly name for that, so open close command, and then click OK. So it will update everywhere. Now if you see here what action it has to actually do, so if you see here, it is just was having in the drop down. So I will create the input zone, because push button is an input to something. Okay, so now if you see, it has created two states for the push button. One is true and one is inverted. Inverted is the false. Okay, so these are the two states for this particular push button which we will need to utilize. As we are using valve, so I will go to the automation layer, and I will choose valve monster. Okay, so valve function block I will use, and then we can configure the valve function blocks. So these are basically the function blocks which are predefined. Now if you see, we have open command and we have the open inverted command. So means true is to give the command and false is to close the command. Okay, so now at open, when I give an open command, what should be the valve position, and when I give a close command, what should be the valve position. So based on that only we will be defining here. So what I'm defining is, if I give the command as open, then it should go to the position which is called work position, and if I give close command, it should go to the home position, means at a 0. So that's how exactly I'm trying to define it here. So I created here the home position, and then here I'm creating an out zone for the work position. Okay, so based on the command, how exactly it will do. So this is what we also define in logic, correct? So we are mapping it. Okay, so we are modeling the behavior. Now to do the cause and effect part, we need to go to the system layer. Now if you see, all the zones what we have defined, all the variables what we have defined has been pre-populated into the system layer. So what are the steps and what are the commands which will be utilized? Now, this particular cause and effect has been divided into, we need to remember few of the commands for this particular cause and effect, like S is for sequence, I is for interlock, then we have D1, D2 is for decision making. So here I am going to utilize very basic, so it is sequences mostly. Okay, so now the first thing is the open valve command. Okay, so what is my first step is open valve command. So from the top, what I'm showing here is zone in, zone out, zone in, out. So these are the kind of variables which we define. So var in, var output, var in, out mostly. So that, and var. So these are the 4 zones which is defined like that. Now open valve command, when I'm saying, so at what valve should get open, this step should get executed. So when I press the open close command button, so we have open close command button which is true, so not inverted one but the normal one. So when I click on that to become true, the sequence of the open valve command will get executed. Similarly, when the valve open feedback we will receive, so when my valve state should go to the working position. Okay, so that's the sequence. So wherever I am defining these sequences, it means that when the state of that particular variable change, this particular sequence will get executed. That's what exactly it means. So when I'm defining it as a S sequence, that exactly it means. Okay, so similarly I have defined it for close valve command and close valve feedback also. Now if you see whatever we have defined, if I go to the MXIC, then here you see that all those mappings are also getting done, that with manual button what action are getting done. So all the checkboxes, if you see, they are getting mapped with the proper variables. Okay, so now we will save it. The last part is the PLC code. So if you see, it is automatically getting updated or creating the PLC code also in this particular view. Now what will be the next step? So here if you click on any of the zone, you will see what is the input, what is the data type, everything you will be able to see about that particular zone. Okay, the naming and everything. Now we need to generate the code for the PLC. So we will click on the generate PLC code. So once you will click on that, it will open a pop-up menu, and then we have to provide the name of the file in which we want to save it. So basically this is an open PLC XML file format which is getting created when we are exporting it. Okay, so once it gets exported, it will show you in the message log that the file has been exported. Now the second phase comes for the CoDeSys part. So I have created the CoDeSys project here by default, and what we need to do here is, let me just enable the emulator for CoDeSys Windows. Now yeah, so we will go to the project and click on the import PLC OpenXML and click on the file which we had exported. So now if you see, it has the whole structure created, and we will be able to import it. So once we import, a POUs folder will get created, and inside that everything will come. So it will be divided into plant, global, and the hardware zone. So inside plant we have two section. One is global, which are defined for the global variables. Another is the hardware zone, which is local, and everything for the sequence and the will be defined under the hardware zone, and the IO mapping, everything will be defined under the hardware zone. Okay, so now once we have imported, one thing which we need to do also is the export the libraries for the Selmo library, because it is using the Selmo structure. So Selmo has already created their own library, so that library we need to export. Okay, so I have already exported this particular library, and then what we need to do is we need to install by clicking on the library repository and click on the install and select the particular library and click on open. So this particular library will get imported and getting installed into our library manager, and then we can go and add library by searching Selmo. Okay, so Selmo basic, click OK, and now if you see, all those message warning has been gone. So after that, what is the next step is So everything is defined under the global control. So this is the main task so either we can call this inside the PLC program, or maybe we can define it inside the task. So I'm defining it inside the main task. Okay, and so if you see, it checks for the license and everything, and then call all the programs which are needed to get operation. So once I compile, so I get some error. Okay, so these errors are for because address is not defined, as it is looking for the IO mapping, because these were the input and output hardwares, correct? So the command is coming from somewhere, the feedback is coming from the valve, so it is for that purpose. So that is why these are right now not defined. So I will just remove this address and then we will see. Okay, so this part is done, and let me save and compile. So okay, so we have the 0 error. Now let's download the program into the emulator, and then we will see how exactly the logic work. So let me give the admin password, and then go for the login download. So once it get downloaded, okay, so now the next part comes in picture is to generate the HMI. So in the Selmo we can also generate an HMI for whatever the logic we have created. So that is one interesting thing which I found, that it will show you all the sequences and nothing we have to do. So it will create this Selmo sequence. So sequence 1 which was defined. Okay, now if I go here, so right now it is showing index X. So let me start the emulator, and so it will show you the sequence what we had defined during our operation, our logic layer basically. So to go the sequence into automatic mode, so we need to first enable the automatic mode, and then there's global automatic release. This particular button we need to click for 3 seconds, then it will come in line, and now the sequence can be started. So once I give a command to the valve as true, so this is the valve, so I will give the command as true to open. Now if you see, it will start the sequence and to show you how exactly it is moving. So from open valve command it moves to step 2, which was to run a timer for 5 seconds. It will run for 5 seconds, then it will wait for the feedback. If feedback is there, then it will move to the next step. So if you see, it moved to the next steps. Okay, so it moved to the close valve command. Now if I give a valve command close, then it will move to step 6, which is there to run the timer for 5 seconds, and then it will check for the feedback, and once the feedback is there, it will go back to the main step 1. So this is the sequence which is getting run, and it is showing into the HMI also. Another way also is there to see this particular sequences, so the way we had defined it into the logic layer. Before going to the logic layer, let me show you that we can also operate, apart from automatic mode, we can also operate them in the manual mode. So whatever the push button we had defined, so if you see, they are also getting created in this HMI, and we can be able to test it using this push button. So position to work, so when we click, it will be true. When we make it to position to home, then it will be false, and the feedback changes. So this is the way which we can do the manually. And if you see here, it can also show you the whatever the sequence we had defined, and then the logic layer can be also seen in this particular mode. So now, as I was telling, that sequence we can see also in the logic layer mode. So if you see here, this is what we had defined, and when we go for automatic, then it will get executed, and every block will show the sequence where exactly it was. So it will show the same way, means how exactly it was running. So let me start it, and then we can see with each steps getting progressed into this. So let me give the command. So let me just make it small. Yeah, so when I give the command, then if you see open valve command, it will go to the next step, which is step 2, where it will run some timer, and then same way it will go to, after getting feedback, it will go to step 4, run the timer, and then when it will go to the next step, we will give the close command. So exactly this is what I was trying to show, that each and every step you can be able to visualize in this how exactly the logic is working and behaving. So this is all on the sequence part, how actually the sequence is getting executed. So apart from this, let me show you that if we do some mistakes on our creating the logic, and then how exactly it shows. So for example, if you see here, all these blocks are showing with a red mark, okay, because there is no linkage between the start step and other steps. So if you see, this link is broken, and that is why everything is red if it is showing. So if we connect it manually, so just drag and connect it over, then all those links get corrected and it will not show in the red mark, and we can be able to generate the code. So that is one thing which we can be able to see, and it is very intuitive. Another thing is that what we have here, if you see, we had the assembly repository, correct? So from here we can be able to export this repository, the FB template, and from this FB template we can be able to also create our own assembly repository and import it into the Selmo again. So right now what I'm doing, I've exported, I'm importing it into the CoDeSys to show you how exactly. So if you see, these are the basic function blocks which have been getting created with the basic logics, but it has to be having some structure which we need to maintain. And if you're using that, then based on that we can create our own assembly repository, and we can push it into the Selmo, so it can work in both ways. So this is the sequence part which I was talking, that these are the some bits which we need to remember to put into the cause and effect. So how exactly the steps and commands should be working. So 0, interlock check, sequence check, monitoring, decision path, jump, cancel. So these are the basic bits which we need to have in mind. The last part is what is there is to export the documentation. So whatever we have done in the application, everything will be coming into the documentation part without any effort. So we can export it, and then the whole documentation will get created for this. Okay, so if you see, this is what the documentation is getting created, and it will have all the assembly part. So all the different zones, system layer, everything will be coming inside this particular documentation. So it helps us to even generate the document pretty handy. So yeah, that's all in this video. So I will try to cover in a snapshot what exactly the feature it is able to provide. I find it intuitive, so I thought to share with you guys. And if you want to get more details, so let me know. Thanks for watching. That's all for this video. See you in the next one.